And welcome to another episode on Sir Boach TV. And today we are looking into calculus. Now we'll be doing 4 parts of this calculus because we'll be looking at differentiation, integration, application of differentiation, and application of integration. Now I want you to stay glued so that we take this thing one after the other and look at it. This very video we are about to start with is differentiation. And the differentiation, we'll be looking at limits, we'll be looking at limits of infinity, and everything about differentiation. We will look at it here. So I want you to stay glued to your seat and let's take our time and learn this once and for all. Alright, so let's start with limit of a function. Now, what is a limit? We say that a limit tells us the value of function is approaching as s gets closer and closer to a certain number. So that is a limit. Now, there is a limit, but s is approaching a. It doesn't mean that s is a. We are saying that s is approaching a of, let's say, 2x plus 4. It means that x is approaching a. A is not yet a. That's why the definition says that a limit tells us the value a function is approaching as s gets closer and closer to a certain number. So as it is approaching that number, it gives us the value of that number, that certain number. So with this one, as it's approaching a, we are going to get 2a plus 4 because we were going to put this a at where we see the x. So we are going to get 2a plus 4. Now, what we have to do is that we do a direct substitution. We do a direct substitution. Then we get our answer. Now, let's take an example. So we have find lim as h approaches 3 of x squared plus 2x plus 1. Now we are saying that x is approaching 3. So it means that anywhere I see x, I'm going to put 3 there. So that we know the value we will get. We will get a value as s approaches 3. And that is what we are looking for. So we are going to get 3 squared plus 2 bracket 3 plus 1. Now 3 squared gives me 9 plus 6 plus 1. And the answer is going to give us 16. The answer is going to give us 16. And this is the value of x. And this is the value as x approaches 3. Is that okay? That is the value as s approaches 3. Let's take another example. If we have lim as s approaches 2, then we have x squared minus 4 all on x minus 2. We are saying x is approaching what? X is approaching 2. But if we look at this question, we can see that the numerator can be broken down because we can change the numerator to a difference of 2 squares. Okay, then we will break it down and know a particular number, then we'll work with it. So this is what I mean. So we are going to get x minus 2 and x plus 2. Why are we getting it? Because if we have s squared, we can also get 2 squared because 2 squared is 4. And difference of 2 squares, we are going to get this statement from difference of 2 squares. Is that okay? Then all over x minus 2. So x minus 2 and x minus 2 will go away. Then we are left with what? X plus 2. Now remember we said lim as x approaches 2. So now let's put 2. We are going to get 2 plus 2. And the answer is going to give us 4 as our final answer. It is so simple like that. Now the next one I want us to look at is limit at infinity. Now, limit as infinity also has a different approach. Infinity, we use the sleeping 8 as infinity as far as function is concerned. So if we have a question, then we say as x approaches infinity. You see that when x was approaching 2, we substituted 2, right, into everywhere we saw x. Then we simplified. But if it's approaching infinity, before we substitute, we have to make sure that the x has been reduced in the question. What do I mean? Means that we will divide each term by the highest value of x, or by the highest exponent of x, so that we can cancel out and we will get we will get a number with limited x. Then we can put in infinity, then we get our final answer. Let me do this practically. So example, we have lim as s approaches infinity. Then we have 3 s squared plus 5 all over x squared minus 2. Now, with what we have right now, we can't just start by putting in the infinity. No, we have to first break it down. And which of the x has the highest power? We will see that the highest power of x here is square. So we will divide each term by the highest power. So we are going to get 3x squared all over s squared for the 3x squared. Then plus 5 over x squared all over s squared over s squared minus 2 over s squared. Now from there, we will cancel. This x squared and this s squared will cancel. S squared goes here 1. It goes here to 1. Is that okay? Now from there, we are going to get 3 here. So 3, then plus 5 on x squared all over x squared over x squared gives us 1 minus 2 over x squared. Now we have limited the highest power of x. You understand? So now we can put in our infinity. So we are saying that lim as x approaches infinity. Let me rewrite it again. So 3 plus 5 over x squared over 1 minus 2 over x squared. Now we are about to put in infinity. So to put in infinity, we are going to get 3 plus 5 over infinity all over 1 minus 2 over infinity. Now if you type 5 over infinity, like 5 over a big number on your phone, maybe 5 over 9, 8, 5, 10, like plenty numbers, you still get a plenty number. So those ones will go to 0. Is that okay? So we are going to get 3 plus 0 over 1 minus 0. And that is going to give us 3 over 1, which is equal to 3. And that will be our final answer. And that is how we solve lim as x approaches infinity. It's so simple like that. Now let's take another question on that. So if we have lim as x approaches infinity, then we have 2x plus 4x cubed over x plus x cubed. Now we want to find this lim as x approaches infinity. What we have to do first, we have to break down the highest power. Okay, so we divide each term by the highest power of x. So we are going to get lim as x approaches infinity 2x over x to the power 3 plus 4x to the power 3 over x to the power 3 all on x over x to the power 3 plus x cubed over x to the power 3. So this is what we have. Now let's do some cancellation here. Now s cubed and s cubed will cancel. S cubed and s cubed will cancel here 1. Now x will cancel here one of them. So we are going to get x squared here. Then this x will cancel 1. It will cancel here x squared. Is that okay? So from there, we are going to get something like lim as x approaches infinity. We are going to get 2 over x squared plus 4 all on 1 over x squared plus 1. Now let's put in infinity. So we're going to get 2 over infinity plus 4 all on 1 over infinity plus 1. Someone will say that, say, why are we putting infinity but we will not use it? It's very important. The examiner would like to see that you are putting infinity there. So don't make a mistake with that. Now, what we will do now, let's put in, we are putting infinity. Now let's simplify. So 2 over infinity will be 0 because it is going to give a plenty number. So we're going to get 0 plus 4 all over 0 plus 1. And that is 4 over 1. And that's going to give us 4. So the answer for this is also 4 as x approaches infinity. All right, so we are about to move to limit with simple trig functions. Okay, so trig functions like sine, cos, and tan are continuous everywhere in their domain. This means most of the time you can simply substitute them directly. Is that okay? However, two very special limits cannot be found by substitution. So now, I wouldn't talk much about this. Let's just get straight into it, but with some examples. Okay, so let's take example. If we have lim as x approaches, let's say pi over 2 of sine x. You see, it's just sine x, so we can just substitute our pi over 2 over there directly. That's what I'm trying to say. Sometimes you can just put it there directly because it's just sine x, and sine x, you just put it there directly, then you get your answer. So we are going to get sine pi over 2, and sine pi over 2 is going to give us 1. So our answer is 1. This is the official and formal definition of a derivative, how it is done. Now we say that f prime of x is equal to lim as h approaches 0. Then we have f bracket x plus h minus f of x, like this, all over h. We have it like this. Now this formula states means that when a question is given, anywhere we see x, we are going to put x plus h over there. That's what it means. Anywhere we see x, we are going to put x plus h over there. Now let me take a question on that, and let's see how we are going to do it. Now let's take an example. So example, we are using the formula. We are differentiating using the first principle. This is the first principle. Okay, this is the first principle. So differentiation with the first principle. So we have f of x being equal to x squared, and we have to differentiate this using the first principle. Now we are saying that if we are using the first principle, then this is the first principle. That's what we are using. So anywhere I see x, I'm going to put what? X plus h over there. Anywhere I see x, I'll put x plus h over there. Is that okay? So let's go. So using the first principle, we are saying that f prime of x being equal to lim as x approach h approaches 0. Then we are going to get, because x is here, I'm going to put x plus h over there. Then we square it. We have minus f of x. And what is f of x? F of x from the question is what? 2. X squared. So minus x squared. So this is what we have all over h. So now you are using the first principle. So this is what it will be. Let me explain again. We are saying that anywhere we see x, we are going to put x plus h over there. So from the question, from the f of x here, we change this x to what? X plus h. Then we continue with what? F of x again. So minus x squared. Now we have x plus h square. We have to break it down. We have to expand it. Okay. So with the x plus h, we are going to get x plus h and another x plus h. Then we are going to simplify to get x square, s times s square, plus xh plus another xh plus h square. Then we are going to get x square plus 2xh plus h square. So this is the simplification of x plus h all square. So we will put it and come and replace it at where we see it in the f prime of x. So we have f prime of x and lim as h approaches 0. Then we'll put in this over there. So it's going to give us x square plus 2xh plus h square. That is from the x plus h square. Now we continue with minus x square all over h. So still lim as h approaches 0. If we open, we are going to get x square minus s square is going to give us what? 0. So we are going to get 2xh plus h square all over h. Is that okay? Now, if we look at the numerator, we will see that we have two terms, and we can factorize h out. So when I factorize h out, I'm going to get h lim as h approaches 0. Then I'm going to get h out, then 2x in plus h. Is that okay? All over h. Then we go ahead to cancel this and that. We are going to get lim as h approaches 0. We are going to get 2x plus h. Now let's put in h. If I put in h, I'm going to get 2x plus 0. And our final answer is going to give me what? 2x as the final answer. For using the first principle differentiate, we are going to get 2x. And that is our final answer. It's so very simple. Now let's pick another question on that again for clearer understanding. So we have f of x being equal to 3x plus 5. F of x equals to 3x plus 5. Now we know the formula to be f prime of x being equal to lim as h approaches 0. Then we have f of x plus h minus f of x, okay, all over h. So anywhere I see x in the f of x, I'm going to put x plus h over there. Is that okay? So let's put in. So you're going to get lim as h approaches 0. So 3, then x is coming. So I'm going to put what there? X plus h over there. Is that okay? Then minus f of x is what? 3x plus 5. Then all this all on what? H. Now from there, this one has no square. So we are just about to open the bracket. So we are going to get lim, okay? We are going to get lim as x approaches 0. As h approaches 0. 3x plus 3h. Now remember that the f of x is minus. So we are going to get minus 3x minus 5 all over h. Is that okay? Good. We will multiply through this bracket with this negative over here. So we are going to cancel somehow. We are going to see that 3x and minus 3x will be 0. So we are going to get lim as h approaches 0. 3x and 3x minus 3x will be 0. So we are going to left with what? 3h minus 5. Is that okay? All over h. 3h minus 5 all over h. Now from there we can just split. Okay, we can just split. So we are going to get lim as h approaches 0 we're going to get 3h over h minus 5 over h. Then this and that will cancel. So we are going to get lim as h approaches 0, 3 minus 5 over h. Now let's put in, they say h approaches 0, so let's put in 0. So we are going to get 3 minus 5 over 0. And 5 over 0 is something we don't even want to write. So the answer is what? 3. So if you differentiate with the first principle, 3x plus 5, you are going to get 3 as your final answer. That is it. Now let's look at another question again that has probably cube, and let's see how that one will work. So we have f of x being equal to x cubed, f of x being equal to s cubed, and we are using the first principle. Now what are the principles say? The principle says that f prime of x being equal to lim as h approaches 0, then we have f of x plus h minus f of x all over h. So anywhere I see x in the f of x, I'm going to put what? F plus h over there. So now let's see. We are going to get lim as h approaches 0. Now x is what? X plus. So I'm going to get x plus h cube minus bracket x cube, because the f of x is what? S cube. Then all on h. Now from here we are going to pick only the x plus h and expand x plus h cube and expand and come and bring it, and then we bring it back. So let's pick our x plus h cube, then expand. So we are going to get x plus h, and also another x plus h. So let's do the two first. So we are going to get x times s will give me x square, then x times h will give me plus xh plus another xh plus h square in a bracket multiplying by h plus x. Then we are going to get x square plus 2xh plus h square brackets close multiplying by x plus h. Now we are done with, we are about to do the third one. So we are going to get x square times s give me x cube, then plus x square h plus 2x square h, 2x square h, then plus 2xh square plus xh square, sh square plus h cube. That's what we are getting when we simplify. Now we can break this down a little bit. We can see that this x square and this also s square, this and this can be simplified, and this and that can also be simplified. So we are going to get x cube plus 3x square h plus 3xh square plus h cube. So that's what we are getting, and we are putting it on this one. We are replacing it with this one, just that one. Is that okay? So let's replace it. So let me continue with it. So this one like this, then we'll continue with minus what? X cube all over h. Now if we expand, we will just move the bracket. After we expand, we realize that this is x cube and this minus x cube, so it will cancel. Is that okay? It will automatically cancel out. Okay, after we cancel, then we are going to get lim as h approaches 0. We are going to get 3x square h plus 3xh square plus h cube all over h. Now we can see clearly that there is h throughout, so we can factorize h out. So we are going to get lim as h approaches 0. If I bring h out, I'm going to get 3x square Is that okay? Plus 3x each. Now, I'll take my time to explain this aspect because we are going into deep. So, how differentiation is done if we are not using the first principle. We use the first principle when we are asked to use the first principle. That's when we use first principle. But if you are not using the first principle, we can just do it magically and we will get our differentiation. Now, let's say we have 3 x cubed and we want to differentiate. Now, the rule is that if I have x to the power n and I want to differentiate, I'll first multiply the n by the x. So I'm going to get n x. Then I'll subtract 1 from the n, that's the superscript, that's the power. I'll subtract 1 from it. Then I'll get my answer. So I have x to the power n. I'll first multiply this n by the x. So I'll get nx. Now the power over there, I'll subtract 1 from it. Then I'm going to get n minus 1 upstairs as a subscript. Now let me take my x to the power 3. So it means that with this one, I'll multiply this 3 by the x. So I'm going to get 3x. Then I'll subtract 1 from the power here, 3. So I'm going to get what? 2. So this will be my answer. So simple. So let's go like 4x squared. And I want to differentiate. What I have to do is I have to multiply this 2 by the x. And there is 4 there already. So it will be like 4 and the 2 will come. Then x will come. Then I'll subtract 1 over here. That will raise the power 1. But 2 times 4 is 8. So that will be 8x to the power 1. To the power 1 is the same as x. Do you get me? Good. Now, let's move to some basic rules when it comes to differentiation. Okay. Now, if you find d dx of a constant, you get 0. It means that if a number is standing alone, and you are differentiating, let's say 4, 5, 7, 9, 12, it's standing there alone and we are differentiating. It means that it will give you 0. Now let's see a proof for that. So let's take 12 and we want to differentiate 12. 12 is standing alone, right? So, and we know that any number raised to the power 0 is 1. So if I even add x to the power 0, it's the same as 12 because x raised to the power 0 is what? Is 1. 1 times 12 is 12. So it means that I have to multiply the 0, x raised to the power 0, by the 12, and I'll get 0. And I'll subtract 1 from it again, and it'll still give me 0. So that's why we say it is 0. Is that okay? So x raised to the power 0, if it's a constant, it means that it's x raised to the power 0, because the question comes in a form like this. Let's say x cubed plus s squared plus x plus 4. Let's say 4. So you see, it keeps reducing. So if this is 1, it means that here too is x raised to the power 0. And that's the constant. So every constant has x raised to the power 0. So when you are differentiating, we multiply the numerator 0 by the constant. Then we will get 0 because it will be 0. So 0 times whatever number will give you 0. Then we need to multiply the x and still give you 0. So that's what it means. Now, the second basic rule that we have to know is that when we have, when we call it the constant multiple, if we have a constant, okay, we can multiply by the function and do whatever we want to do with it. Is that okay? So if we have a constant, maybe we have something like d over dx, d dx, c multiplying what? F of x. Is that okay? And then that will give us c multiplying f of x, like that. It's simple like that. It's just a simple note that we have to know. We are not going to even use this one the match. Now let's come to more differentiation. Let's make an example. If we have y being equal to x to the power 5, we want to find x to the power 5. We want to differentiate. We are not even fine. We are differentiating x to the power 5. So the first thing that will bring the power, that's the 5, down to come and multiply by the x. So we are going to get 5x. Now the power 5 will subtract 1 from it. What will be left to be 5 minus 1. So we are going to get 5x to the power what? 4. And that is our answer for y is equal to x to the power 5. Is that okay? Now let's take questions under polynomial to how to differentiate a polynomial. So let's say we are differentiating y being equal to 4x cubed minus 7x squared plus 2x minus 9. We are differentiating this. Now when we happen like that, we are going to differentiate it term by term. Now what is a term? Someone said what's a term? If I have 3 plus 2 plus y, that means we have 3 terms. The symbols we have differentiate the number of terms we have. So we call this one a term, we call this one a term, and also call this one a term. So we have 4x cubed minus 7x squared plus 2x minus 9. It means that 4x cubed is a term, 7x squared is a term, 2x is a term, and 9 is also a term. 9 is also a term. So we will differentiate it term by term. So our first term is 4x to the power 3. Now what we are going to do is that we multiply the numerator, or we multiply the power of x by the 4, and we are going to get 12. Then we bring my x, then I'll subtract the power, that's the 3, I'll subtract 1, that will give me what? 2. I'm done with the first term. Then I continue. I'll multiply these 2 by minus 7. I'm going to get minus 14 x. Then I'll subtract 1. That will give you x to the power 1, the same as x. Then I'll move ahead plus 2x. The x has a power of 1. So I'll multiply the 1 by the 2. I'm going to get 2. If I subtract 1 from the power here, it will be 0. So I'm not going to bring it again. Then a constant is always 0. So this becomes our final answer. When we find d dx, we find dy dx of this. So we had for y is equal to 4x cubed minus 7x squared plus 2x minus 9. So our dy dx give me 12x squared minus 14x plus 2. Now, what happens when we have a negative power? It follows the same idea, but let's look at it. So we are going to get, we have y being equal to x to the power minus 2. So we are finding dy dx. So we multiply the minus 2 by the x. I'm going to get minus 2x. Then I'll subtract 1 again from the power. So you are going to get minus 2 minus 1. That will give me minus what? 3. So we are going to get minus 2. We are going to get minus 2x raised the power minus 3. Let's also take another one in case we have a fraction. So let's say y being equal to x raised the power 1 over 2. We follow the same way. So we are finding dy over dx. So we bring the 1 over 2 down. So I'm going to get 1 over 2x. Then we subtract 1 from this. Is that okay? And that was going to give me minus 1 over 2. So that will be our final answer for that one too. It's so simple. Differentiation is so simple like that. Now let's come to something very important again. Let's come to product rule. Product rule. Now when it comes to product rule, there is a method that we need to work with. We cannot change it. There is a formula. Let me put it like that way. There is a formula we use introducing letters like U and V before we can solve it. Now, what will happen is that when we have two polynomials to differentiate, what will happen is that we are going to introduce u and v, and the u and v will come and take part of the to come and take charge of the two terms polynomial. Then it will help us to simplify it or to differentiate it better. All right, so let's get straight into that. So we say that the ddx of u and v will give you u inverse u prime of v, okay, plus uv, like that. So it is u prime of v plus v prime of plus uv prime. Again, u prime of v plus uv prime. Now, saying it like this, it will be plenty. Let's take a question and let's look at it. So we are going to have y being equal to x squared plus 3 in one bracket, and also x cubed minus 2x is on another bracket. Now, we can't just start by just factorizing and factorizing, because there are two terms. We have to first give it different terms or different letters, u and v. So we will say let u be equal to x squared plus 3. So du over dv being equal to du over dx, okay? Du over dx is going to give you 2x. Then we will say let v also be equal to x cubed minus 2x. So dv over ds also give you 3x minus 2. Now we see that we use v and u to replace the two terms of the polynomial. So and we have differentiated with respect to that letter that we used. Now from there, the rule is telling us that to find dy dx, it is du over dx multiplying by v plus dv over dx multiplying by u, and that will give us our answer. So our dy dx will be equal to, now du dx we got what? 2x. So I write my 2x. And what is my v? My v was this. So that's x cubed minus 2x. Is that okay? Then we continue. Plus dv dx. Dv dx is 3x minus 2. Then u is x squared plus 3. X squared plus 3. So from there, what we have to do? We have to simplify. We can't leave it like that. So we will break it down. We will simplify. So now let's simplify to get our dy dx. So if we multiply 2x by 3 cubed, we are going to get 2x to the power 4. Then 2x times minus 2x is going to give us minus 4x. Then my plus sign will come. Now 3x times x cubed is going to give us 3x to the power 3. Then 3x times 3 is going to give us plus 9x. Minus 2 times x squared is going to give me minus 2x squared. And minus 2 times 3 is going to give us minus 6. Minus 6. Minus 6. So from there, let me go through my expansion again, whether it is correct. So 2x and x cubed, we're going to give us 2x to the power 4. 2x and minus 2x is going to give us minus 4x squared. That's the first part. Then plus. Now 3x and x cubed. 3x and x cubed 3x and x cubed. Is it x cubed or x squared? Okay, sorry, x squared. Okay, 3x squared. Oh, this is supposed to be square. Okay, 3x squared, 3x squared and x squared is going to 3x to the power 4. Okay, so there was a mistake there. All right. Then we continue by 3x squared times 3. That will be 9x to the power 2. Now minus 2 times x squared is going to give us 2x minus 2x squared. And minus 2 times 3 is going to give us 6. So that's the breakdown. Now from there, we will see the common ones and work with them very fast. So we can see that there is 2x to the power 4 here and 3x to the power 4. So we are going to get 5x to the power 4. Now we can also see x squared and x squared. 9x squared minus 2x squared is going to give us plus 7x squared. Then I'll continue with what? Minus 4x minus 6. Minus 4x minus 6. And that becomes our answer for the polynomial. Differentiating the polynomial. 4x to the power 4 plus 7x plus 7x square minus 4x minus 6. That's our final answer. Now let's take another one. Now let's move to quotient rule. Let's move to quotient rule. Now with the quotient rule also have a very specific formula that we have to use. Now the formula says that for quotient rule, the formula says that your dy dx should be equal to u prime of v minus u v prime all over v square. So it means that with this one too, we will make a u and we will make a v from the question. Then we will differentiate them. After we differentiate them, then we bring them here. But this time, we are using minus. Remember that the product we will use addition. But the quotient rule, we are using subtraction. And we are dividing everything by v square. So let me quote it. The product was dy dx will give you du over dx multiplied by v plus dv over dx multiplied by u. But this time it is the same thing, but this time we are using subtraction and dividing everything by v square. So quotient is also equal to dy over dx being equal to, so du over dx multiplied by v, okay, minus dv over dx multiplied by u. Then we divide everything by what? V square. So these are the difference. Then these are the two differences between the difference between the formulas. Now let's pick a question and see how it will be done. So we have y being equal to x squared plus 1 in a bracket all over x minus 3 also in a bracket. We have to differentiate this. Now we can't just differentiate it directly like that. So we are going to introduce v and u. So we are going to say let u be equal to x squared plus 1 and v will also be equal to x minus 3. So we will find u over dx and that will give me 2x here. Then the v over dx will also give me 1 here. So we are getting 1 for dividing the x and 2x for du dx. Now from there, we will use the formula and mount it on it and see how it will be. Now let's get straight. Well, now the formula says that to find dy dx, then it has to be dv over dx. Let me start with u. Du over dx multiplied by v, then minus dv dx multiplied by u all over v square. All over v square. So let's put in the values. So du dx is 2x. So 2x multiplied by v, and v is x minus 3. Now we come to the other side, minus dv dx is 1 multiplied by u, and u is x square plus 1. Then I'll divide all this by v square, and v square is what? X minus 3 all square. Now what we are going to do is that we are going to simplify the top, the numerator. So let's go. So 2x times x is going to give me 2x squared minus 6x minus x squared minus 1 all on x minus 3 all square. So from the top, 2x squared minus x squared will give me x squared. So I'm going to get x squared minus 6x minus 1 all over x minus 3 all square. Now we are not done. We can see clearly that the top has taken us to quadratic. So we will pick the top and solve it quadratically. After that, we come and mount it on it. Then we continue. Because we have to get 2 terms. Is that okay? We have to get 2 terms. So we will solve the top quadratically and come and mount and simplify. Some people will leave their answers in this, but I don't think it's the best. So let's solve the numerator. I'm going to get x squared minus 6x minus 1. So we multiply the coefficient of the x squared by the constant is still 1. Now we're looking for factors of 1 that when we multiply we get 1, but when we add, when we multiply we get 1, but when we add we are going to get 6, and there's nothing like that. So I think we'll leave our answer like this. But in the case whereby it can be simplified, we will go straight to simplify the numerator and mount it on the denominator. Then we get our answer. Now let's move to chain rule. Chain rule also has its own formula that we used to do. Now, when we are multiplying two functions, f of x and g of x, now what will happen is that we are going to introduce letters as we are doing already, but this time we are going to differentiate it with respect to that particular thing. So we say that dy over dx for chain rule will give you dy over du times du over dx. So it means that we have to find we have to change the letter to u. Then we find dy du. Then we also come and find what du dx. Then we multiply. Then we get our chain. So that's how the chain rule works. So most of the time, this chain rule will happen whereby when we are having a lot of where the power is huge, maybe x plus y all raised to the power 7. Those kind of formulas, those kind of questions, that is where we introduce the chain rule. Okay, because if we say we are factorizing, we have to first multiply that term by 7 times. Now let's take a question. You understand what I mean? So y is equal to 3x plus 2 all raised to the power 5. Now a question like this, if I say I'm not using chain rule, I have to multiply 3x plus 2 5 times. And look at the huge numbers I will get before I will come and what? Before I will come and differentiate. But there's a simple chain rule method that we can use. There's a simple chain rule method that we can use. We can just say that we are letting a letter take charge of the 3x plus 2. Is that okay? So that after we finish, we will bring it back and we'll get our answer. Is that okay? So how is it going to be? So we are going to say let UB is equal to 3x plus 2. So if it happens like that, then our y is now u to the power 5. U to the power 5. Then here we will find du over dx. And du over dx is going to give me 3 here. And here we will find dy over du. And the y du is also going to give us 5u to the power 4. 5u to the power 4. Now from there, what do we do? They say we should multiply, we bring it together. So our dy over dx is simply dy over du multiplying by du over what? Dx. And this is going to give me 5u to the power 4 times 3. Then yu to the power 4 is going to give me 15u to the power 4. So our dy over dx is going to give me 15u to the power 4. But we said u is equal to 3x plus 2. So let's fix it. So now our dy over dx is equal to 15 bracket 3x plus 2 brackets close to the power 4. That is our final answer. You see how simple it is? We just make the equation, we will make the term in the bracket as a letter, then we differentiate, then we just come and put it back, then we are done. It's so simple like that. So very simple like that. And that is how chain rule works. But let me know in the comment section if you have any challenges when it comes to differentiation, where particularly you have the problem. Let me know and I'll take my time to explain it so that we get a better understanding of it. The part that you think that it is confusing, we will look at it together. Now let's look at higher derivatives. Now if I have x to the power 5 and let's say y is equal to x to the power 5 and I'm finding dy over dx, I'm going to get 5x to the power 4. That's the first derivative. We have a second derivative, we have a third derivative. Now the first derivative is just differentiating the function dy dx, but the second derivative is differentiating the dy dx again, and the third derivative is differentiating the second derivative. What do I mean? If I have x to the power 5 as my function and I find the first derivative as dy dx, that is 5x to the power 4. If I want to find the second, if I want to differentiate again, it's no longer going to be dy dx, but it's going to be d square y over ds square. Meaning I have to differentiate this one again. So 4 times 5 gives me 20 x to the power 3. And that is what we call second derivative. Differentiating 2 times. Second derivative. Now if I go with d cube y over ds cube, it means that I'm going to the third derivative. So if I differentiate the 20x cube, I'm going to get 60x squared. That is the third derivative. So I differentiated this one. The first time I got this, that's the first derivative. Okay, the first derivative. And I differentiated this one again, and I got this. We call it the second derivative. And I differentiated this one again, and we got this. And that will call it what? The third derivative. So if the question asks you to find the second derivative, it means that differentiate 2 times. If the question asks you to find the third derivative, it means differentiate 3 times. Is that okay? Now let's pick a question over here. So let me pick a very interesting question. It says find all derivatives of f of x being equal to x to the power 4 minus 3x cubed plus 5x minus 2. So it means that because we are telling us to find all the derivative, means that we are differentiating until we get 0. When we get 0, we will see all the derivative. Now it can be written as, you see, because the question is in f of x. If the question was in y, we will say dy over dx. But because it is in f of x, we will call it f prime of x. It's the same thing. If it's y, we'll call it dy dx. But if it's f of x, we'll call it f prime of x. Is that okay? So I'll use f prime of x. So we'll say f prime of x. That's the first derivative of this. I'm going to get 4x cubed minus 9x squared plus 5. Plus 5. Because if I differentiate 2, I'm going to get 0. And if I differentiate 5x, I'm going to get 5. If I differentiate 3x cubed, I'm going to get minus 9x cubed squared. And if I differentiate 4 x squared, x raised to the power 4, I'm going to get 4x to the power 3. Now we are not done. That's the first derivative. So the second derivative will be f prime of x. That's the second derivative. F prime of x. So if I differentiate again, I'm going to get, if I differentiate 4x cubed, I'm going to get 12x squared. If I differentiate 9x squared, I'm going to get minus 18x. Then if I differentiate 5, I'm going to get 0. So I will not bring it again. Is that okay? We are still not done. So if I go to the third derivative, is first f prime of x. That's the third derivative. So if I differentiate this one, I'm going to get 12 times 2 gives me 24x minus 18. That is the third derivative. Then from there, my fourth derivative is f prime of x, and that will give me 24. If I differentiate 24x, I'll get 24, and I'll get 24. And if I differentiate 18, it's a constant, so I'll get what? 0. We are still not done. We will do the last one again. So that is f prime of x. Differentiating of 24 will give me 0. So that is how it is. So simple like that. So we'll find all the derivatives. So maybe after this, they can ask you what is the second derivative, what's the third derivative. Then you just be looking at it and you'll be answering your questions. Now we want to look at, all right, so we'll continue by looking at how to find the minimum point and the maximum point at the turning point, and also the turning point. Now the simple way to find the maximum and the maximum point is that d square y over ds square. If d square y over ds square is greater than 0, it means that it is minimum point. If it is greater, rather, it is minimum. Take note. And if d square y over ds square is less than 0, it means that it's maximum. Okay, it means that it is maximum. Now I want us to look at a question that we are to find the turning point. And before we find the turning point, we have to first find the minimum point and the maximum point before we move ahead to get our turning point. So what we are going to do is that first we'll find dy dx for the equation. After that, we will equate dy dx equal to 0 and find two values of x. We'll find the values of x. So we find the value of x, then we would come and find d square y over ds square. That's the second derivative. After that, we put in the value of x that we found inside. Then we get our maximum and our minimum. Now, talking too much about it will make it look plenty. So let's do it together. So example, if I have y being equal to x cubed minus 3x, we are finding the turning point. Okay, so that you're finding the maximum and the minimum point. Now, first we'll find dy dx. So our dy dx will be equal to 3x squared minus 3. 3x squared minus 3. Then we will set dy over dx to be equal to 0. So we are going to get 3x squared minus 3 being equal to 0. 3x squared minus 3 being equal to 0. Now, what will happen is that we are looking for x, and we are sure that we are going to get two values of x. So we can even break it down. We can break this down by dividing here by 3, dividing here by 3, and dividing here by 3. So I'm going to get x squared minus 1 being equal to 0. Then we go ahead to get x squared is equal to 1. That's positive 1. Now to find x, I'll square root here and I'll square root here. Then x is equal to plus or minus 1. So we are saying x is equal to 1 or x is equal to minus 1. Now after we are done finding the value of x, we are saying, you see, we have gotten two values of x. We have gotten two values of x. So right now what we are going to do is that we are going to find the square y over the x square. So we know our dy over dx is equal to 3x squared minus 3. So the square y over the x squared is equal to 6x. 6x. So now we are going to put the value of x that we got into the square y over the x squared. So remember, we got x is equal to 1 and also s is equal to minus 1. And our d square y over the s square is equal to 6x. So let's put it in. We'll put each of them inside. So this is going to give us 6 bracket 1. That when we put 1 there, and that's going to give us 6. So because 6 is greater than 0, so dy ds is greater than 0, we call this our minimum. Okay, then we'll do the same thing for d square y over d square y for 6x. Then we put in 6 bracket minus 1. Then I'm going to get minus 6, and that becomes our what? Our maximum. Is that okay? So our minimum is our minimum value is 1, and our maximum value is minus 1. Okay, that's what it means. Our minimum, because you got 1 and minus 1. Which one is minimum and which one is maximum? Maximum. You wouldn't know until you find your second derivative and put in the values of x. So the negative one becomes your maximum and the positive one becomes your minimum. Now let's move to implicit functions. Implicit functions. All right, so let's take our first example. So we have find dy over dx for x squared plus y squared being equal to 25. Now we are to differentiate this. Now differentiating this, we are going to differentiate the term by term. And with the implicit, what will happen is that anytime we differentiate y, we are going to add dy dx to it. Anytime we differentiate y, we are going to add dy dx to it. Now let's go. We are going to get x squared for this one. For x squared, we are going to get 2x. Okay, let me write a question. X squared plus x plus y squared being equal to 25. Then I'm going to get 2x plus 2y, but I'll add dy over dx being equal to being equal to 0. So 2x squared gave us 2x, then y squared give us 2y, then we added our dy dx to it. Then differentiation of 25 will give me 0. Now from there, what do? We are finding dy dx. So we are going to get 2y dy dx will give you minus 2x. Then divide here by 2y and divide here by 2y. So our dy over dx will give you minus x over y. And that's our final answer for dy dx. We can't do anything to this again. Now let's look at a situation whereby they are mixed. X and y are mixed together. So let's pick a question like x squared y plus y cube being equal to 10. X squared y plus y cube is equal to 10. Now, with this type of implicit, because x and y are together, we will factorize them. Though they are together, we will we will differentiate them differently. We will hold x and differentiate y, then come and hold y and differentiate x. This is what I mean. So we have x squared y. First, we differentiate x squared. We are going to get 2x. Then we add the y. Then after that, plus we bring the x squared. Then we differentiate the y to get dy over dx. So that's what the expression of x squared y, when differentiated, that's what we'll get. I hope it's clear. So we differentiate the x squared, then we maintain the y. Then we come and differentiate. We come and maintain the x squared and differentiate the y. We differentiate the x squared and maintain the y. Now maintain the x squared, then differentiate the y. So that is what it means. So we are going after differentiation. That's what we are going to start with. So we are going to get 2xy plus x squared dy dx being equal to 0, because 10 will give me 0. So from there, we are looking for dy dx. So we'll move the 2x squared to the other side of the equal to sign. So we're going to get x squared dy over dx being equal to 2xy. So we divide here by x squared and divide here by x squared. X squared and x squared will cancel. Then my x dy over dx is going to give me. Now I can cancel one of the x's here with the one at the denominator side. Okay, let me write it here. So we are going to get dy over dx being equal to 2xy over x squared. So my dy over dx will be equal to x cancels here 1, it cancels here x. You're going to get 2y over x as our final answer. So this is how implicit function is. Anytime you are working on implicit function, you have to make sure that when they are together, when the x and y are together, you hold one. So you hold x and differentiate y. Then after that, you come and hold y and differentiate x. But if they are singles, you move directly. This is what I mean again. In case we have 3xy plus x plus y being equal to, let's say 40, let's say 2y, okay? And you see that the 3x comes with the 3x has y to it, so it's 3xy. So for the 3xy alone, you are going to get 3x, then you differentiate the y to get dy dx. You see, I didn't do anything to the 3x. I left it like that. Now, after I'm done with differentiating the y, I'm going to hold the y and differentiate the x. If I differentiate 3x, I'm going to get 3. Then I'll add the y to it. Just like that for the 3xy. Then I'll come to x. When I differentiate x, I'm going to get 1. Then if I differentiate 2y, I'm going to get 2, because it's y, it's going to change to dy dx being equal to what? 0. Is that okay? So with this one, I'll group like terms. So I'm going to say 3x dy over dx plus 2 dy over dx being equal to 3y will move to the other side. That will give me 3y, then minus 1. Now, when we have this, what we can do is that we can bring dy dx out. Then we are going left with 3x plus 2 being equal to 3y minus 1. Then from there, we'll divide both sides by 3x plus 2. Then I'm going to get dy on dx being equal to 3y minus 1 over 3x plus 2. That will be our final answer. When we differentiate 3xy plus x plus 2y being equal to 140, that is the answer that we will get. So thank you very much for your time. I know this is a long video, almost an hour, and thank you very much for your time and your patience, and I hope you have learned. Whatever you don't understand, let me know in the comment section. I'll take my time to pinpoint the places where you have issues or you didn't understand for you. My name is Boach, and I'll see you again. I'm out.